Hello class, today we're going to learn about 2.1 solving simple equations. So let's start off by looking at how we just solve equations here. Here we have an expression 3 plus 4 plus 5 minus 4. If you did this following BEDMAS, you would do 3 plus 4, which is 7, plus 5, which is 12, plus minus 4, which is 8. Similarly, if you look at this expression, 3 times 5, divide by 5 plus 6. You would follow BEDMAS and do multiplication division first. So you have 3 times 5, which is 15, divide by 5, which is 3, then add 6, which is 9. This last one here is, if you follow BEDMAS, you just go left to right. 8 plus 3,289 is 3,297, minus 3,289 brings you back to 8, then you add 4, which is equal to 12. If you looked at this very closely, you might notice that there were some similar operations, but different slightly. If you look at these, you'll notice that the pairs are the same value, but different signs or different operations. So instead of adding 4, you subtracted 4. Instead of multiplying by 5, there was a dividing by 5. Instead of adding 3,289, we subtracted 3,289. So if we look at that, one way what we could do to get to the same answer is because these are the same value, different operation, they kind of cancel each other out. So by adding 4 and subtracting 4, that operation doesn't really exist anymore. So all you'd be doing is doing 3 plus 5, which brings you to the answer of 8. Similarly, in this equation that we did earlier, times 5 and divide by 5 would cancel each other out. So you're just doing 3 plus 6, which is 9. And then the last equation we did is you add and you subtract. So all you have left over is 8 plus 4, which is 12. Okay, so what you will notice is that when we find these pairs, what they are is they're identical numbers, but they're the opposite operations. And in the end, it doesn't affect the end answer. We still got the same value if we did follow BEDMAS in this first example. But if we just cancel those same number, different opposite operation, they kind of cancel each other out. Okay, so how's that going to help us solving equations? Well, we need to apply that in the sense that when we're dealing with an equation, for example, 5 plus 5, that means that the left side is equal to the right side. And so right now, the left side is equal to 5, the right side is equal to 5. If I add 1 to both sides, it's still equal. The left side is still equal to the right side. And so it doesn't matter if I multiply by 2 on the left side and I multiply 2 on the right side, again, my equation is still balanced. How that's going to help is that we can do something like this, where if I need to solve an equation that is x plus 4 equals 12, what I can do is I want to solve for x, which means I want to isolate x so it's by itself on the one side. So by doing that, I'm going to need to get rid of this plus 4 that is currently attached to my x. How I'm going to get rid of it is by subtracting 4. If I subtract 4 on one side, though, I have to subtract 4 on the right side to make it balanced still. And by doing that, now our plus 4 and our minus 4 is that same value, opposite operation. They cancel each other out. So all I'm left with on the left side is just x. But on the right side, it's 12 minus 4. So therefore, x is equal to 8. And I haven't affected the equation the whole time the equations were balanced, and so I can solve the equation. Try these questions out below and see if you get similar. Remember, you're always trying to use the opposite operation to get rid of what's with the x, so you can isolate for the variable. All right, and sometimes the variables can change. It can turn into n, for example, in this example here. So what you will hopefully have noticed now is that the trick to isolating a variable is to move numbers away from the variable by applying the opposite operation. So if you think of the opposite operation, what are they? Well, for addition, it would be subtraction. For subtraction, it would be addition. For multiplication, it's division. For division, it's multiplication. And then if you have an exponent of 2, then it's the square root, okay? So the exponent of 2, to get rid of that, is the opposite of that is square root. All right, so try out the questions, read over the lesson, and good luck. If you have any questions, make sure you reach out.